Chapter 5 is on probably one of the most important, I think, things from a management perspective to understand about business and about pricing in your business, but is commonly overlooked for as important as it is. I think the stuff we are going to start talking about in this chapter is seriously management level stuff. This is the kind of stuff that if you understand it and you're sitting in a meeting and you start to talk about price elasticity of demand, people are going to sit up and listen, okay? So I would encourage you to try your best to understand this concept, because not only is it on your exam, but it just is a fundamental part of running a business. Today, we're going to cover most of elasticity of demand. Then we're going to finish it up on Wednesday, and I believe next Friday we're going to do some worksheets and work out some problems, okay? Elasticity. We're talking about the responsiveness of consumers. Elasticity is in movement, right? The elasticity of demand measures how responsive consumers are to changes in price. We know that when you increase the price of your good, it's going to decrease quantity demanded. We know when you decrease the price of your good, it's going to increase quantity demanded. We already know that. The question that this answers is, well, how much more or how much less? This is very particular to the good that you're selling. And so being able to measure the price elasticity of demand for your particular good or service, I think is of the utmost importance. I love this chapter because it really geeks me out about really understanding what you can do to make your business successful in terms of pricing. There might not be anything more important than that, okay? Choosing the price of your good. So the calculation, you'll need to know this. I'm going to break this down for you more. So you don't necessarily need to write this down yet. Wait till we get to the next slide. But the calculation that we use for price elasticity of demand is percentage change in quantity demanded divided by the percentage change in price. So in other words, if we change the price, how does quantity demanded change as a result? And we change that into percentages because straight numbers doesn't really give us the information we're looking for. So we change it into percentages. So if I take you to the next slide, okay, if I was going to write one down to have right next to me for the exam, it would be the second one here that I've kind of broken down into actual components for you that I think you could just then plug numbers into. So this one on the top here, that's exactly what you and I already talked about. Percentage change, the delta is the change, percentage change in quantity over percentage change in price. But here I've broken it down a little bit more. How do we calculate percentage change in quantity? Well, it's a little bit different than if I was saying to you in a math class, come up with the percentage change. Because we use something that's called the midpoint formula in this particular calculation, because we're actually calculating a range of elasticity. Sorry, a range of elasticity across prices. So how we would do that, how we would set that up is we would put the change in quantity, quantity's on top, right? It's in the numerator position. So how do we calculate the numerator? We take change in quantity divided by quantity plus quantity prime, or quantity 1 plus quantity 2, right? Our quantity's changing from one quantity to another. So what's the beginning quantity and what's the ending quantity, okay? Add them together and divide by 2. What's another way to say quantity plus quantity prime divided by 2? Thank you, average quantity, right? That's how I would remember it if I were you, right? Because we all know how to take a simple average. So change in quantity over average quantity. We do that calculation, and that is our numerator, okay? And then to calculate our denominator, it's going to be the change in price. We're changing from one price to another, right? So there's an ending price, a beginning price and an ending price. So we're going to add those prices together and divide by 2. So change in quantity over average quantity divided by change in price over average price. Everybody good? This, you got to know this or have it available, right? This just sort of explains to you what some of the symbols mean, right? But a delta, we're talking about change. All right? So let's walk through a quick example. This is the example from your author, okay, in your textbook. And I'm going to do it here on the board behind me. So here we have a market for tacos, right? We're thinking about decreasing the price from $1.10 to 90 cents. These are our tacos, okay? And so we're trying to figure out if that's a good move or not. Well, if we have an idea of what our demand curve is, which we should, right? We might not, we might have to guess, take an educated guess. And we decrease our price to 90 cents, we know people will demand more, a higher quantity. We just don't know how much more. Well, we look at our demand curve and it's going to give us what that second quantity is, right? We decrease our price, it does increase the quantity. But is that a good move for us? Well, we need to figure out what the price elasticity of demand for our tacos is. And if we can do that, I can actually tell you by doing that calculation if you should decrease the price of your tacos from $1.10 to $1.90. I'm sorry, to 90 cents. Okay? So let's plug the numbers into our calculation and see if we can figure this out. Okay? All right, so what do we need first? We're going to work from top to bottom. So let's do our numerator first, right? What do we need? This is the percentage change in quantity, right, is up here. And the percentage change in price is down here, okay? What do we need first? Look at your calculation. What's up here? Change in quantity, right? Percentage change in quantity. So change in quantity over average quantity, right? So what's our change in quantity? Easy. We're going from 95 to 105.
20 cents.
10,000.
We're not doing price yet. Hang on to price. We're doing
10,000.
quantity. Thanks, Dennis. That's going to be 10. Okay. Change in quantity over average quantity. Well, average quantity, right, is going to be 95 plus 105 divided by 2. It's going to give us 100, right? It's going to give us 200 divided by 2. Everybody good? All right, now we're going to do the price part. Change in price. I think somebody said it earlier. 20 cents. Okay, we're going from 110 to 90 over average price. Our average price, 110 plus 90 divided by 2. Okay, that's going to give us $1. Any trouble with this so far? Or is everybody good? Yeah, pretty straightforward, right? Okay, let's do this calculation. 10 divided by 100 gives us 0.1. Okay. 0.2 divided by 1 gives you 0.2. You do this math and you come up with a 0.5. 0.5 is your price elasticity of demand. Well, you don't really know what this means yet. We'll get to the next slide, okay? Now, let me just explain something really quick. We could have thrown some negative numbers in here, because actually, one of these is negative, right? This one here, the price is actually going down 20 cents. And a lot of my colleagues and a lot of economists would be like, you got to put that in there. Well, yeah, maybe. But when we calculate price elasticity of demand, we end up taking the absolute value in the end anyway. A lot of times students get confused. If they put the negative in here, then they want to give me a negative answer here, because they forget to take the absolute value. So had we done this with the -1, we would have come up with a -0.5. Then we would have taken the absolute value of it, which is 0.5. For any of you that care, okay? Your price elasticity of demand is never, never, never negative. Never negative. If you give me a negative answer on an exam, it's all wrong, okay? Even if you've done the calculation right and you get to the end, if you give me a -0.5, it is wrong, okay? So make that note someplace. All right, any questions about the calculation? All right, so let's go on and talk about what that means. So in this case, we have a number between 0 and 1. We have a 0.5, which means that we have seen inelastic response by consumers between those prices. Consumers didn't respond like we wanted them to respond. Okay? Your other two options would have been unit elasticity, that's here with an absolute value of exactly 1. That is fairly unrealistic. That would just be like some random coincidence that you ended up with that. But it ends up being a threshold. Just, you'll see on a graph that it's more conceptual than actually practical, this unit elastic concept. And then elasticity means that consumers were very responsive to a change in price, and we would get some value over 1. It could be 10, could be 20, right? Don't get scared of big numbers. It happens, but it's something greater than 1. So we experience inelasticity. That means that we decrease the price at a greater percentage than people responded in an increase in quantity demanded. You should not lower the price of your taco from $1.10 to 90 cents. You shouldn't do it. And I know by doing this calculation that consumers just didn't respond to your decrease in price, okay? Had this been a 2 or a 1.5 or a 10, I'd say go for it. Decrease the price of your taco. You're going to see a good increase in quantity demanded. It's going to not only make up for that decrease in price, but it's actually going to give you more overall revenue. Let's talk about that drink at McDonald's, that huge one. What is that, the biggest drink at McDonald's cost you? You all know. It cost you $1. It wasn't always $1. You're probably too young to remember, but at some point that drink at McDonald's was like $2.79. It went from $2.79 to $1 for a limited time only a decade ago, because they were testing out price elasticity of demand. They sold so many more $1 drinks that they actually make more revenue on large drinks at $1 a piece than they ever did large drinks at $2.79 a piece, because they understood price elasticity of demand. which I hope McDonald's has an economist on staff. I'm sure they have several, right? Trying to figure this out. But they actually were spot on. They picked a price that not only got you and I to buy more drinks, but it's actually a marketing tactic too, right? It gets us into the drive-through sometimes when we're just looking for a drink, and then we add something else onto our order, right? So it's twofold. It was genius. It was genius. So anytime you see somebody offering you a good at a lower price for a limited time only, they're testing your price elasticity of demand. If it goes back to the regular price, when it's all said and done, it's because it just didn't work out. It was more inelastic than they thought. This is a really, really important thing to know about your good, okay? Any questions about that? This taco example that your author did, this is a terrible example. And I'm going to tell you why. Because tacos in general have a lot of substitutes, right? A lot of substitutes. Goods that have a lot of substitutes should have really elastic demand, because consumers can be very picky, right, about how much they want to spend on something. And if the price goes too high, they'll simply just go buy something else. So your author clearly is talking about a very, very particular taco that people can't seem to find a substitute for, okay? Not realistic, although I have met one of these tacos, right? We probably all have, that probably has more inelastic demand. But I would think in general, when we're talking about a taco that's $1.10, we're talking about a fast food Taco Bell taco, right? Okay. And there's lots of substitutes, right? There's 30 things on the menu, and there's 10 other drive-thrus on the same street. Those are all substitutes for you. And you and I we know this because we talked about the law of demand and the substitution effect, that when prices get cheaper compared to other goods, we substitute in the cheaper good and substitute out the more expensive good, okay? So this is a weird example for your author to have chosen, but just gives us something to talk about. All right, so here's kind of the important part. Here's why calculating elasticity is a thing. Because it impacts revenue, right? It's all about the dollars in the end. Revenue, by definition, price multiplied by the quantity demanded at that price. So revenue is the money coming in the door. We're not talking about profit, right? That's a totally different thing, and we'll get there. That's actually our ultimate goal in this class, is to talk about profit. But we start with revenue. So when we are experiencing elasticity, that would mean if we decreased our price, which might be an addition you might want to put on this slide or make a note of. Here we're talking about if we start at the top of a demand curve, a downward sloping demand curve, and we're decreasing price and working our way down, okay? If we decrease our price and total revenue increases, so we're decreasing our price, but we're actually bringing in more money, we're experiencing elasticity. Consumers are responding to that decrease in price. We should probably decrease the price, okay? Unit elasticity, remember, we talked about how that's just kind of a threshold, so don't get caught up in that. And we experience inelasticity when total revenue decreases as we decrease our price. That's what would happen in our example. That's actually what's happening here, is that our total revenue is actually decreasing as we decrease our price. Leave your price at $1.10 on those tacos, okay? Don't want to change that. So before we get to the graph, let's talk about the demand curve that you're about to see. It's the demand curve I showed you in the last chapter. It's a perfect straight line, downward sloping demand curve. Very unrealistic, something you're never going to see in real life, but in these principles classes, it's really the concept, it's the takeaway we want you to get, and so we just try and make it as simple as possible for you, okay? So what you're going to see is a straight line demand curve with a constant slope. How do we define slope? Does anybody remember? Right? It's going to be rise over run, right? So when we're looking at a downward sloping demand curve, right? It's the rise over the run. Well, this would indicate to me that with every decrease in price, you know, because price is along the Y and quantity is along the X, for every, let's say, $1 decrease in price, we're going to have the same exact increase in quantity demanded at that price. Okay? So you're going to see in the example why this gives us a nice, neat, clean example to work with. But that's all this slide is telling you. All right, you're not going to like this, okay? This is sort of us bringing everything we've just learned together, and for some of you, this is a lot, okay? For most of you, this is a lot. So what you're looking at here is a demand curve for just some typical good with a normal good with a downward sloping demand curve. You can see as the prices go down, quantity demanded goes up just like you would expect to see. It has a constant slope that we talked about. But we're going to start to talk about a demand curve in terms of elasticity. So if you look at this demand curve, you'll see, don't look at all the shaded boxes underneath the demand curve. Just look at the demand curve for a minute. You'll see it's sort of labeled, right? With C being a point of unit elasticity, that's that threshold where elasticity is equal to 1. And that the portion of the demand curve above that is elastic, and the portion of the demand curve below that is inelastic. Most of these regular, and we'll talk about exceptions when I see you a week from today, but most of these regular demand curves are going to experience elasticity at higher prices and inelasticity at lower prices. And here's why. Is because you and I as consumers respond to decreases when prices are higher and being discounted than when prices are lower and being discounted. So for example, if you were told you were going to get, 10% off on a car you were looking at, that is a lot of money, right? Because the price is high. And so you're going to be more responsive to that discount. If I told you that the pack of gum that you're going to stop and get at the Circle K on the way home saw a 10% decrease in price, that's probably not going to drive a lot of decision making for you because it's not a lot of money, right? It doesn't represent much. And so that's the general principle behind why we experience elasticity at higher prices and inelasticity at lower prices. It's about just consumer behavior. Don't overthink that, just take my word for it, okay? So let's look at what happens. Let's say this is the market for like a pair of jeans, okay? And you can see there's no demand at $100 a pair. And then we start to see demand starting anywhere below that, okay? But you can also see the slope, that constant slope. With every $10 decrease in price, we get a 100 unit increase in quantity demanded. So you can see that. That's what slope indicates to me, okay? Or those are the thresholds that we've picked anyway. If we sell $90 jeans, we're gonna sell 100 pair. If we sell $80 jeans, we're gonna sell 200 pair, so on and so forth all the way down. Let's look at the difference between pricing our jeans at $90 and pricing our jeans at $80. If we're looking at this graph trying to make that particular decision, the difference between pricing at 90 and pricing at 80 is huge in terms of revenue. If we make the decision to price at $80, we're giving up the opportunity to sell those first 100 units at a higher price, but we're gaining the revenue from selling 100 additional pair at that $80 price. So that first area A, if we actually calculated, like using your geometry formula, the area of that square, you know, base times height, base of 100, height times 10, we would see that that represents the loss in revenue we would see from decreasing the price instead of selling at 90, selling at 80. But at the same time, we saw an increase in revenue because we got to sell an additional 100 pair at $80 a piece. So area B, if we took the physical area and calculated it, would be 8,000 in additional revenue. So we sacrificed 1,000 in order to get 8,000. Is that a good deal? Sounds like a good deal to me. Should we decrease our price? Should we decrease it from that original 90 that we were thinking we might sell it at to 80? Absolutely. Okay, you sell it at 80, you're going to make more money. As we continue to work our way down, decreasing price, we're actually going to continue to increase revenue by decreasing price until we get to that point C. And then at point C, it switches on us. And as we begin to then decrease price below $50 or point C, we will see the opposite thing happen. So you can see as we go from 20 to 10, area D is the amount of our loss by decreasing the price, and E is our gain. So you can see it switches. So you actually don't want to decrease your price from 20 to 10 because you're losing revenue. So it's a constant slope, but as we move down it, this calculation begins to change from being elastic to inelastic during for the duration of those price ranges, right? So going from 100 to 50, we're seeing elasticity or responsiveness as we decrease price. Then from 50 to 0, consumers are not being as responsive as we decrease price. I know it's a lot, okay? But we'll work with it a lot before you're expected to do homework or do an exam, okay? All right. So the second thing on here that we've added is this total revenue curve. And there is a reason it is sitting directly below, because it's related, right? It's creating a relationship for you. If we sell 0 pairs of jeans at $100 per jean, we're not making any money, 0 revenue, right? Revenue is price times quantity. So as we work our way down here, right, we can sell 100 pair at $90 a piece. That would give us 9,000 in revenue. That's probably right here, okay? And then we could sell 200 units at $80 a pair. That's 16,000. That's here, right? And if we kept doing that calculation at different prices and quantities, we would increase revenue until we got to, this isn't a coincidence, right? Until we got to our unit elastic point on the demand curve. And then as we decrease the price, revenue would go back down. These are all, these are all points, all the points along this curve we could calculate, right? We could calculate all the different prices and quantities sold at those prices, quantities demanded at those prices, and we could plot this revenue curve. Right now, I'm just trying to get you to recognize the relationship between elasticities, demand curves, and revenue. Questions? It's too early for all this, right? No questions at all? Okay, so just to clarify, most regular demand curves are going to be downward sloping, be more elastic at the top and inelastic at the bottom. For those of you who are going to start working on your homework, you're going to recognize there's something else, right? And that's that demand curves have different slopes. Because while every demand curve, not every, every downward sloping demand curve is going to experience both elasticity and inelasticity, there are actually goods in and of themselves that are more inelastic or more elastic. And it has to do with the number of substitutes for that good available. So we talked about tacos, why this is an unrealistic price elasticity for tacos. Tacos have a lot of substitutes, so consumers have a lot of leeway to be responsive to changes in price. What is a good that you can think of that might experience more inelasticity in general? Because there maybe aren't that many substitutes.
Alcohol.
Like alcohol in general, like the entire category of alcohol. Sure, okay. You do buy more at a lower price, I think, but overall, that could be true, right? People are gonna pay for alcohol if they want it. What else? What types of goods will you not really buy more or less of if the price changes?
Vinegar, oil.
Say it a little louder.
Vinegar, maybe oil, I don't know.
Sorry, I can't hear you. My speakers. Hang on. Let me see if I can get it. Nope, not my speaker, my screen. Okay, try it again.
Vinegar, oil.
Huh. Yeah, I mean, that's an interesting choice. I don't know how much more or less, but you're right. People just use a certain quantity, right? But I bet if the price went up high enough, you and I wouldn't use as much. What are things that are really inelastic?
Medication.
Thank you, right? So especially like life-saving or life-sustaining medication. Oh, hand sanitizer, that's a good answer, Maggie. Life-saving medications. If you have something that you have to take every day, you take, let's say, 1 dose a day, there's really no reason for you to buy more if the price goes down. And there's really not really an option for you to buy less. Do some people buy less? Sure, if the price goes up too high. You know, we've seen that happen a couple of times. But chances are, if it's a life-sustaining medication, you're gonna stop buying something else to give you more money to continue to buy your medication, right? Yeah, so something like that would tend to, because there aren't a lot of substitutes for your medication, right? It's life-sustaining, you need it, okay? So tacos, more elastic in general, life-saving medication, more inelastic in general, okay? We'll talk a lot more about this. Any other questions? All right, this is a good place to stop. This is where we'll pick up a week from today. Remember to do your chapter 4 homework. Have a good weekend.